In this video we're continuing with the topic of trigonometry and looking at the wave function, and this is the second of two videos on the wave function. So this is example 3, and we want to write 4 cos x plus 3 sin x in the form k times sine of x plus alpha, where k is greater than 0 and alpha lies between 0 and 360 degrees. So before we go ahead with expressing that in that form, just want to have a wee quick look at the graph of 4 cos x plus 3 sin x equal to y. So you can see it looks something like that, and we'll come back to that later on. So we're asked to express it in the form k of sine of x plus alpha, and expanding that will give us k times sin x cos alpha plus cos x sin alpha. And multiplying throughout by k gives us this k sin x cos alpha plus k cos x sin alpha. And we can now look at equating coefficients, and we can see that k times cos of alpha is equal to 3, and k times sin of alpha is equal to 4. Now we have our simultaneous equations. We need to look at solving those. Firstly, we'll solve for k. We'll square each of our equations to get k squared times sine squared of alpha is equal to 16, and squaring our other equation gives us k squared times cos squared of alpha equal to 9. And if we add these together, we get k squared times sine squared of alpha plus k squared times cos squared of alpha is equal to 16 plus 9. On the left hand side we have a common factor of k squared, and on the right hand side we can evaluate that, that's 25. Remember, sine squared of alpha plus cos squared of alpha is equal to 1, and we can then conclude that if k squared is 25, k is equal to 5. We now need to solve for alpha, so if we take our equations, we have k times sine of alpha over k times cos of alpha is equal to 4 thirds. Our k's will simplify to 1 here. And remember, sine of alpha over cos of alpha is equal to tan of alpha. So tan of alpha is equal to 4 thirds. And to know which quadrant your angle is coming from, we can use the cast diagram here. Okay, so k sine of alpha was positive, so that means our answer could be in the first or second quadrant. And k cos of alpha was also positive, so answers coming from the first and fourth quadrants. So that means our answer for alpha will come from the first quadrant here. So inverse tan of 4 thirds is equal to 53.1 degrees. And we now have all of the information to express 4 cos x plus 3 sin x in the form k times sine of x plus alpha. So that will be 5 times sine of x plus 53.1 degrees. And if we just look at the graph of 5 sine of x plus 53.1 degrees, you can see that it matches exactly the 4 cos x plus 3 sin x graph of that. So just now it would be a good idea to pause the video before the screen goes blank, take this example down your notes, and then complete the assigned exercise for today.